Okay, so today we are going to see um, how to simplify a summation like this. Now, the purpose of this is um, that this summation does not is usually asked as a full question to students, but sometimes we are simplifying something and a summation like this appears in an intermediate stage of the solution. So sometimes we need to simplify that into a simple relationship. So let's see whether we can find a one-term answer for this summation or not. So we all know of the binomial theorem, which says that the nth power of a sum can be given by this, where this nj is actually a combination and choose j, and this is a to the power of j and this b to the power of n minus j. Now note that if I substitute a by some parameter p and b as some parameter 1 minus p, then this a plus b becomes 1, and 1 to the power of anything is 1. And on the right hand side, my summation would look like something like p to the j and 1 minus p to the n minus j. Now what I'm interested in is finding this sum for only even values of j. So this means I will use n choose 0, and then n choose 2, and then choose 4 up to the maximum value of n. So let's see whether we can solve it or not. Now let's consider this sum. This sum we already know that this is equal to 1, and this sum is the same sum, but now p is replaced by minus p here. Now if you think, then this sum has the same terms for even j as this sum, and the sum of these terms for odd j is the additive inverse of the sum of these terms for odd j. So for example, if we have n choose 3 p to the 3 1 minus p and minus 3, then we have n choose 3 minus p to the 3 1 minus p and minus 3 here. So if we add them both, then we will see that even terms will add up and odd terms will cancel out. Okay, so then this becomes 2 times sum containing only even value of j. So which means that this guy is equal to what? This guy is equal to 1, as we have already seen, and this guy is equal to what? This guy is equal to minus p plus 1 minus p to the power of n, which is actually 1 minus 2p to the power of n. So we get 2 times this sum is equal to 1 minus 2p to the power of n, which means that we can bring this 2 on that side, and which means that this summation is now equal to 1 plus 1 minus 2p to the power of n divided by 2 here. Now what if we want to calculate the odd terms? For odd terms, all we have to do is we have to go back to this summation, and for here, in terms of addition, we will subtract. Now if we subtract, it is easy to see that now even terms will cancel out and odd terms will add up. Okay, and then we get 1 minus 2p here, 1 minus 1 minus 2p to the n here. Okay, and so this summation actually is used a lot when simplifying, for example, probability questions with discrete probabilities, when we have a success parameter p and failure parameter 1 minus p.